Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me for yet another video in the Rust programming tutorial series. Now, up until this point, we've been covering a lot of fundamental concepts in Rust, anything from building custom data structures to dealing with the primitive data types to dealing with the vec type or handling threading and things of that nature. But one of the things that we still have yet to cover that's part of the standard library in Rust is the ability to interact with the local file system. Any application out there is generally going to need the ability to create files, create directory structures, delete files, change file contents, and things of that nature. Because let's admit it, most of our state, most of the data that we're working with, at least temporarily exists on the local file system, even if we end up moving it to some alternative location like a remote server, like an FTP server, or S3 object storage, or something like that, right? So it's really important to understand the Rust APIs that allow you to deal with the file system. And because there are so many different types of operations on the file system, including things like getting metadata from files, for example, we're not going to cover every single use case here, but we are going to introduce some of the fundamental concepts in the Rust standard crate that allow you to start dealing with the file system. So we'll look at some of the most basic operations, things like creating directories, creating files, reading some contents from files into a memory buffer, and things of that nature. So what we're going to be doing is diving into the standard library here. So feel free to check out the docs for Rust here, go to the standard crate and head down to the modules section right here. And one of the many modules that is kind of exported by the STD module here or STD crate is the FS module. So the FS module generally deals with things pertaining to the local file system. There's a bunch of different types in here, things like directory entries that allow you to get data about files and directories that exist in a parent directory. We have the file type here that allows us to do things with files like open files for reading or write contents to files or things of that nature. We also have things like metadata here that allow us to get some additional information about files. So you can get things like file type. Is it a directory? Is it a file? What's the length of the file? Things of that nature. We've also got permissions down here. When was it last modified? So there's a lot of interesting data that you can get from files using the metadata. We also have this kind of fluent API. I don't know if you heard that term before, but basically it's a fluent API that allows you to call a number of different methods on this type called open options. So you can start with the open options right here, and you can choose if you want to create a new file, if you want to have read permissions, if you want to have write permissions to the file, and you can specify then the file name that you want to open. So if you only need to open a file for writing or only open the file for reading, or if you don't want to create a new file if it doesn't exist, then you can use this open options to kind of specify using these methods right over here, which options you want. Another option that we have here is to truncate an existing file. So any kind of options that you want to set when you're opening a file for an operation, you have the ability to use open options here, but it's not mandatory that you use this mechanism. With the file system, there tend to be a lot of different ways to do the same thing. So don't necessarily look at one person's code and say, oh, I guess this is the right way to do it. There's honestly multiple ways of accomplishing the same objectives, like reading and writing and listing files and things like that. So we're just going to kind of focus on some of the fundamentals. Now, you don't necessarily have to dig into one of these types. Like if we wanted to, let's say, open a file, we could go to this file struct here, and then there's a method on the file type here called open, and this allows us to open a file in read-only mode, for example. And we don't necessarily have to use this particular mechanism in order to read or write a file. There's other options. There's actually some functions that are directly exported by the module so that you don't have to dig into the types or the structs right up here. For example, if we want to create a directory, we don't need to worry about any custom data structures up here. We can literally just call out to this function in the FS module called create dir. If you've ever done a makedir dash dash parents where it can create a hierarchy of directories like subfolder 1, subfolder 2, subfolder 3, and none of those exist already, then you can actually use create dir all, and that will go ahead and recursively create the kind of top level directory, then the next child, then the next child after that, so that you don't have to make multiple calls to create dir here if you want to create a directory structure. So those are a couple of nice helper functions. We also have the ability to just read a directory here using the readdir function, which is part of the FS module. That'll allow us to just iterate over the entries or directories and files inside of a directory. We can also delete a directory by using removedir. We can also use removedir all. That's kind of like doing an rm-rf on some folder path. We can also delete a file with remove file. We can rename a file or directory, and we can also write to a file just using this write method, and then read a file using the read method right up here. These are a little bit less flexible, so if you're trying to do some very precise operations inside of a file, like, seek to the 500th byte and then read 100 bytes and then skip 500 more bytes, that type of thing, you're going to have to kind of reach into the file struct for so that you can have a pointer to the position that you're currently at inside of the file so that you can kind of seek around inside of that file or go back to the beginning of the file and start reading a stream of bytes. But if all you're trying to do is just read a small text file off the file system, then using something like read would work perfectly fine. Now, there are a couple of other modules that could potentially come into play when you're dealing with the file system. If we head back up to the standard crate right here and go down to modules, there is another child module of standard crate called path. And if you are just trying to do something like to check if a path exists, so check if a directory path exists or check if a file path exists, then you can actually just use the path type here. And path actually has a function on it called exists. So you can actually just check and get a Boolean value to see if a file or folder exists or doesn't exist. And you can use that Boolean value to then make decisions or branches inside of your Rust program to determine if you should even try to read that file or not. You don't necessarily have to do that in advance, but it does help kind of improve the robustness of your code. And there are other ways to handle it though. So for example, if you try to read a file and it doesn't exist or you don't have permission or something like that, you will actually get an error from the other APIs that we were just looking at. But again, if your objective is just to kind of check if it exists and move on, then this function right here can help you. And there's a whole bunch of other helpers here, like is it a dir, is it a file, things like that. So path is another module that is part of the standard crate. And then the other one that might come into play for some kind of edge use cases, for anything that's kind of platform specific, there is another module that's in here that allows you to do OS specific things, and that's literally just called OS right here. So we've got, Linux, we've got Unix platforms, we've got Windows here as well. So if we go into the Windows child module, you can see that there's a bunch of child modules in here. And if we go to Filesystem, this functionality is only available on the Windows system. There's a couple of functions in here that allow you to create symlinks or soft links to files on the file system where you can basically reference the exact same file using a different name somewhere else on the file system. Windows also has junction links and hard links and things like that. Those are a little bit more advanced file system concepts that we're not going to be covering in this particular video, but we might be able to cover down the road. But any kind of operating system specific functionality, you might have to reach into this OS module here. But what we're going to primarily be focusing on is, of course, the FS module, which allows us to read and write files and directories. Now, before we actually get into writing some code here, I just wanted to invite you to head over to my YouTube channel at youtube.com/TrevorSullivan, which is almost certainly where you're watching this video right now. Please subscribe to the channel because I'm an independent content creator. Your subscription really helps me to bring more videos to you like this one. And also, please leave a like on the video if you learned something new by the end of this video, or if you just enjoy the presentation style. And also just leave a comment down below on this video and the others in the Rust programming tutorial series, which you can find featured right here on the home tab of my channel. and just let me know what you thought of this series. Let me know what other kind of topics you're interested in seeing as it pertains to Rust programming. I've already got a lot more planned, but I'm always interested in hearing what kind of topics other people are interested in. Also, on the community tab here, you can get updates. If you're subscribed to the channel, you can get periodic updates, and sometimes I post these quiz questions to help test your knowledge to see if you really understand certain concepts that we've covered in videos, and if not, then there should be a video that you can go watch in order to learn about those particular concepts. All right, so we are going to go ahead and write some code for the file system, and I'm going to come back to VS Code, and my very first video in this tutorial series on Rust actually talks about setting up VS Code to SSH to a remote Linux virtual machine. So even though I'm on the Windows platform here locally, which you may have noticed from the window Chrome that I've got right here on my tab switcher, I am actually connected to a Linux virtual machine. So if I just do uname-a, you can see I'm on a Linux VM right here, and we're all good to go. So I'm just going to add in another module into my root project here. I just have kind of a single project, and I'm creating separate module files so that we can kind of categorize our code for all the different topics that we're dealing with. Things like, matching, dates and times, hash maps, hash sets, iterators, multi-channel, multi-threading channels, mutexes, scoped threads, and all that stuff. So I'm going to create a new file here called myfs.rs. And inside of here, we'll go ahead and just define a public function that we can call from main. And let's just do test create dir for now. And we can always create some additional functions in here if we need to. But now we're going to head over to main.rs. I like to typically use the VS Code file switcher. If you just hit Control P on your keyboard, you can just search for a file that you want to switch to very quickly so that I don't have to switch over to the mouse. And we'll comment out this mpsc call and do, of course, I need to declare my module right up here. So we'll say pub mod and then do myfs. And then we should be able to call our function. So myfs test create dir, and now we should be good to go. So if we do a cargo run, we get our hello message, which is right up here at the top of my main function, but then all the rest of our code is going to be in myfs.rs. All right, so the first thing we're going to take a look at is just how to create a directory inside of our file system here. So what we're going to do is just go to the root of our project. So my terminal is currently in my app directory here, which is what I have opened up in VS Code. And right now, we don't have any subfolders aside from target and .git. So let's say that I wanted to create a folder in my project here called data and maybe create some plain text files inside of that data directory. Well, the first thing we need to do is to create a data directory. So what we'll do is call out to fs. So we're going to import the file system module right up here and say use standard fs. And that'll give us access to use all of the functions and data types that are declared in fs. And then what we'll do is just say fs create dir, and we'll go ahead and just do // data. And so that's a relative path from wherever the contextual directory that we're running our program in, which is /app right here under my home directory. This is going to create this data folder right under there. And then you're going to see that it returns a result as well. And you're not obligated to capture the result, but generally speaking, for a robust program, you're going to want to capture that result so you can see if the operation was successful or not successful. So we'll go ahead and assign a create dir result. I know that's kind of wordy, but I just like to kind of make the names of my variables obvious so that we know what their intent is. And then we'll take a look at this, and it returns a unit type, basically meaning that if the operation is successful, then it returns kind of just a null type of value, the unit type in Rust. And then it also returns an error if any kind of error occurred, if we had a permissions error and things like that. So what we'll do is say if create dir result dot is okay. So that means if it was successful, then we're just going to say print line created new data directory. Otherwise, we'll say some problem occurred creating data directory. And then I'll put a couple of curly braces here, and we'll do colon question mark, so we get debug output, and then I'm going to pass in create dir result dot error, and that should give us the error and print out the debug output of whatever that error object looks like. All right, so let's go ahead and run our program here. And I'm also going to open up this sidebar here just so that we can watch to see that folder get created, because VS Code will automatically refresh the user interface as soon as that folder gets created. And sure enough, there it is. Now I've got custom themes applied in VS Code, so you might not see the exact same icon there. It doesn't really have any special meaning, but apparently whoever created the theme for these icons designated that a data directory should have that particular icon. So now the folder already exists, and so if I try to run my application again, check out what we get. We actually get this error being printed out. So this else block right here actually got executed the second time, and it says some problem occurred creating data directory. That's the text that we statically plugged in here. But then after that, it prints out the actual value of the OS error here. And the error kind says already exists, and the detailed message just says file exists. Of course, it's actually a directory, but same kind of concept. All right, so that's how we can create a directory, but remember that we have the path type, which can help us to check to see if the directory already exists or not. If we head back to modules, go down to the path module, we can go ahead and construct one of these path types here and use it to check to see if the path exists or not. So we'll start by just creating a path using this path new function here, and then we'll just call the exists method on it to see if it's there. So what we'll do is say let path equal dot/data, because we want to be able to use this path multiple times. And then over here in the path for create dir, we'll just say path and reference this path that we have right up here. And then we want to check to see if it exists or not. So what we'll do is say if path, actually let's get a reference to the path first. So we'll say let my path equal, actually I'm going to do my underscore path because that's more rustic. And then we'll say standard path, and then capital P path, that's the type. And then we'll call the new function here. And this is just going to take a string slice or a static string as input. And so we'll just pass in a path here, right? So we're going to take this value and just pass it in to construct a new path object. But now that we have a reference to a path object, we can call myPath.exists. And because it returns a Boolean value, either true or false, we can use that in an if statement to make some decisions about how to branch our code. So now what we'll do is say if myPath.exists, then we want to print line and say directory already exists, and say skipping creation ... And then what we can do is just return from our function early. And so if the path doesn't exist, then our function will continue executing, and all of the code down here after this if block will get executed. So what we'll do is just save this, do cargo run, and as you can see, we get our custom message saying that the directory already exists. So by using this particular pattern here, by checking if the directory exists in our own code, rather than just letting an error occur, this is kind of a more graceful way of handling a specific scenario where the directory already exists. Now, we could potentially still run into other types of errors. So maybe the directory does not exist, but that'll skip over this. And then if we try to create the directory, maybe we don't have permission to the folder path that we're trying to create, right? And so we could still potentially get an error that causes this print line statement down here to get executed. But at least we checked to see if it exists or not. So you could add some additional code maybe up here before we attempt to create the directory that says, check permissions or something like that. See if I have permission to the parent directory where we're going to try to create the new directory. And then if we don't have permission, then just skip creating it again. But I'll leave that to you as an exercise that you can go do in your own Rust program. So I think that's pretty good as far as creating a directory. So let's move on to another topic, which would be creating files in our new data directory. So what I'm going to do for this is create another function here. I'll call this create files. And then we can leave our call to test create dir because this is pretty robust code. It's just going to skip creating the directory if it already exists. So that should just effectively leave that directory in place. It's never going to delete the directory or anything like that. So we'll switch back to main. And right after test create dir, we'll do myfs create files. All right, so this should be a pretty safe function to call. Then we're just going to create some files in that data directory. All right, so in order to create files, we'll take a look at the documentation here. We'll go back to the fs module here under the standard crate. And then we're going to take a look at one of these functions here called write. And again, this is just kind of a helper function. This is not the only way to write to a file. Again, if you need to do precision operations like jumping to a specific position in the file and inserting some content somewhere in the middle, then this would probably not be the best function to use for that purpose. But if all you need to do is take some data that you have in memory and then write that out to a file, then this is just a really nice helper. The only inputs that this is going to take are a couple of generic arguments. So we've got the path, and we also have the unsigned 8-bit integer slice, as indicated by these square brackets here, that is going to serve as the contents of the data that we actually write into this file. And it does say right here, this function will create a file if it doesn't exist. So you don't have to do some separate operation to create the file and then write data to the file. This will just kind of handle that for you automatically. And so just be aware of that. Also, this does have a destructive operation wrapping it as well. So if you already have a file and it already has data inside of it, then this function will replace the contents of the file if it already exists. So it will basically truncate the file and then write the new contents that you've specified into that file. All right, so let's go ahead and give this a try. Let's do a standard fs, and then we'll do the write function right here. So all we need to do are provide it the path and contents, and we'll do that by declaring a couple of variables before the call to this function. So right up here, before we actually go change this to insert the arguments, let's do path. We'll say path equals /data file01.txt, and then we'll say let text equal Trevor Sullivan. Okay. So now what we want to do is take these string slices and we want to use them as arguments. So we'll pass in path, and then we'll also pass in the text contents right here. And it looks like Rust is actually going to do an automatic conversion here. So even though we have a string slice here, it's going to be able to interpret that as the appropriate U8 data type that we need to represent these as, because unsigned 8-bit integers are basically byte values where you can have 0 through 255, all positive values, again, because it's unsigned, not a signed integer. And so you can literally take these individual characters and convert them to byte values based on an ASCII table. And that is basically, I think, how it's converting that under the hood. Once again, though, when we call this write method, or write function, I should say, it's not a method on an object, it's a function that's exported by a module, we should get a result back. But in this particular case, it's only going to give us a result with a unit type. It's not going to give us any kind of error handling here. So if we have a permissions error, or if our disk is full, or some other condition occurs, then we're not going to get a very helpful error message. Just something else you want to keep in mind when you're using this simplified method of creating data. So we don't really need to capture the result because we know that we're always going to get back a result wrapping a unit type. So I'm going to use the underscore here The underscore is basically how we can discard a value. So we'll just say underscore equals this value, and that takes away the warning saying that we aren't capturing the result, but it's still going to execute this function right here and basically just kind of pass the value to this empty variable. So what we can do is maybe just duplicate this a couple of times, and I'll just create a couple more variables here called path2 and path3. Of course, it would make a lot more sense to do maybe a for loop across a vec or an array of string values, but for now, I'm just going to hard code a couple of variables. I realize this isn't necessarily the best way of doing this, and we'll just write the same text into all of those files. Actually, let's not. Let's do something else. Let's do Nancy Drew, just so this way, when we read different files, we can kind of see the different contents that we get back, and so we can verify which file we read. And then we'll do Shannon Jones, and then we also need to change our file names. So file 1, file 2, and file 3. And then we need to reference text 2, text 3, and let's see, need to make sure I get that in the right position there. And then we'll pass in path 2, text 2, path 3, text 3. All right, let's give this a run and see what happens. And once again, I'm just going to open up my sidebar here in VS Code, and we'll expand this data folder. Right now it's empty, but when we run our application, do cargo run, we should see those files immediately get populated into that directory. And if we open up file 1, Trevor Sullivan, file 2, Nancy Drew, file 03, Shannon Jones. So everything seems to be working pretty well there. Let's say that maybe we wanted to remove one of those files, right? Well, what we could do is call remove file here. So after we create those 3 files, let's say that we wanted to delete one of them. So what we'll do is say standard fs and then do remove file. And all we need to do is specify the path. So I'll say path2, and that should remove file02.txt right after it creates it. And once again, we've got a result coming back here. And right down here, you can see we've got results is wrapping a unit type. So we don't really need to capture that and do any error handling. So let's do cargo run. And immediately you see file02.txt disappear from our file list. But I'll comment that out, rerun our code, and that should recreate file02. All right, so that's how we can create and destroy files. And let's go ahead and see what happens if we try to delete a directory. So we'll do pub fn remove dir, and right up here we'll say standard fs remove dir, and we'll pass in our path, which is going to be data. We'll say let path equal ./data. And so we'll do remove dir on path, and I'm guessing that's going to return a result as well, which we can always verify in the documentation. Sure enough, it also returns just a kind of dummy result wrapping a unit type here. So that's not particularly helpful. But let's see what we get here, because we do have data inside of that directory. So if we just call remove dir, do you think it's going to work or not? Well, it says this function will return an error in these situations. So the path doesn't exist. Well, it does in this case. Or the path isn't a directory. Well, it is in this case because data is a directory, not a file. And it also says if the user lacks permissions, obviously that's going to prevent us from deleting the folder. And if the directory isn't empty, right? Our directory is not empty. So we are expecting actually that this should throw an error here. So if we do cargo run, of course, I need to actually call that function for it to actually work. So let's do myfs remove dir. We'll do cargo run. And as you can see, it did not work here. It did not actually delete our folder here. So what we need to do in this particular case, because we actually have data inside of this directory here, we actually need to call the other function called remove dir all. So this way, it will delete all of the contents of the directory and finally the directory itself. So this is kind of an rm-rf type of operation that you would typically run from a bash shell. So we're just going to change this to remove dir all. Of course, it just takes a path as input, and now you can see that our data has disappeared. So let's go ahead and comment that out and rerun our application so we can recreate our directory structure right here. And let's practice reading data from these files now. Now, again, the easiest way to accomplish this is going to be with the helper function called read. This is just going to read the entire contents of the file into a vec type that wraps the unsigned 8-bit integer. So we're essentially just getting raw bytes back from the file. It's not necessarily being interpreted as ASCII text encoding or UTF-8 encoding or UTF-16 or Unicode or any of those text encoding formats. It's literally just giving us a vec wrapping the bytes of data. And then it's up to us to interpret what those bytes actually mean. So we could convert those bytes into text once we get them into a vec, right? So let's go ahead and give it a try. We'll say pub fn read some file. And then we're going to specify a file path here. File to read equals /data file01.txt. And then we'll do standard fs and then read and pass in file to read. All right, so what's a little bit different here is that we are going to get a result wrapping a vec, wrapping unsigned 8-bit integers. So in this case, we do have to capture the result. Otherwise, the read operation will occur and we haven't actually done anything with the data. So let's do read result, let read result equal the results of this read operation. And once again, we get a result here wrapping a vec u8, and it is actually returning an error, it looks like. I'm not sure why the documentation doesn't reflect that right here, but it is actually including an error as part of that result. So we can kind of follow a same pattern that we did back down here, where we say if the operation is okay, so if no error occurred, then we can go ahead and print out the contents. Otherwise, we'll just say that some error occurred and we need to figure out what that is. So let's do if read result dot is okay. Then we want to print line and say data found is, and then we'll just insert the values right here. So this is where things get a little bit interesting, because how exactly are we going to represent a vec of unsigned 8-bit integers? Do we want to print out the integer values of each element of the vec? Do we want to do some kind of data conversion ahead of time? How exactly do we plan on representing that data? Well, for simplicity, just to kind of start out and make sure that we actually have some kind of data, what I'm going to do is actually just print out the first element from the vec. So what we'll do is go into our read results. We'll go ahead and say .ok to extract the vec u8 out, and then we should be able to get a value. Of course, this is also wrapped in option. I'm not sure why it doesn't display that in the editor, but we need to unwrap the result, and then we should be able to index into the vec and grab the first element. And that should literally just give us an unsigned 8-bit integer. It's not going to give us a T for Trevor or whatever we have in this file here. So let's do a cargo run. Of course, I think I forgot to call this function again. So we'll go back to main and we'll do myfs and read some file. Let's do cargo run, and it says data found is 84. So what does 84 mean? Well, we are reading file01.txt, right? Let's go look at file01.txt, and we can see that the first element, the 0th element in the vec that was returned by the read function, is going to be a T, but it's being represented as byte data rather than an actual character, right? There's no conversion being done from the raw file data, which is stored physically on the disk as bytes, back to a character style representation. So if we take a look at an ASCII table here, or a character lookup table, right, and we look up the number 84, we should see that that maps to a capital T, right? So when we get 84 as our result, that's actually indicating that the capital T is the first letter. Well, what else can we do? Well, let's grab maybe the second letter. So we'll do an index of 1. That is a number of 114. So once again, if we go to the lookup table, 114 is a lowercase r. So you can start to see that we can do this translation manually by going to a lookup table and actually translating that value. But what if we wanted to take these bytes and actually turn them back into text characters? Well, this is where we need to use the iteration concept that we covered several videos ago, because this is going to allow us to iterate over every single byte in the file and then do some kind of conversion on it. So this is going to look a little complicated here because we're going to have to get the resulting vec, then we have to unwrap it from its option type because it's wrapped in a sum of type byte, or U8, I should say, and then we just grab an element here. But rather than just grabbing an individual element at the end, we actually want to iterate over it by calling .iter on the vec. And so what do we want to do with this iterator? Well, we want to go over every single character and convert it from a byte into a character, and then we want to mash together all of those individual characters into a single complete string that we can print out as a substitute right here, right? So this is going to look a little crazy, but what we're going to do is say iter dot map. Actually, we're going to do dot fold, and fold is actually a function that we looked at in my iterators video, and it's going to take an accumulator and the new value from each iteration. And the accumulator is going to need to be mutable because we're actually going to be mutating the accumulator on every single iteration of a byte that we iterate through on the vec of U8. So what we're going to do here is create this closure that does the translation for us. And to make things a little bit more readable, you can actually define the closure separately and just assign it to a variable and then pass that closure variable into the fold function. And that just makes things more readable. So let's do a variable called convert bytes to string. And this will equal our closure. And then I'll do curly braces here because we're going to need to do a multi-line function here, or closure, I should say, so that we can do this conversion. So what we're going to do is start with the accumulator as a string type, right? It's going to be basically just an empty string. And then what we need to do is specify that we want to push the new value as a character onto the empty string. So we're going to start with the first byte, 84. We're going to convert it to a character, and then we're going to push that character onto the empty string. Now you can see that right here, we are getting an error because it doesn't know the actual data type that we are dealing with. So what we need to do is specify that A is going to be a string type, and V is going to be an unsigned 8-bit integer, because that is what the fold function here is going to end up passing into the closure. So what we need to do is take V and convert it as a character. So we'll say car from V, and we're going to get probably an error here about needing to be a pointer. So I'm actually going to do a deref here. Actually, we don't. So I think fold is actually going to pass in a pointer to it. Let's see if we can get the generated code down here. So I'm not seeing it, but we'll try this in just a sec. So we'll say let new car equal car from V, and then we'll say a dot push, and we'll push that new car onto the end of the string. And finally, we're going to discard that result. I think it returns something. Actually, no, it doesn't return anything. So we'll just leave that off. And then we'll just say return A. So on every single iteration of this closure, or on this fold function, we're going to start with an empty string. We're going to convert the byte to a character. We're going to push that character onto the end of the string. And then we're going to return the total accumulated value, which will be used as the input for the accumulator on the next iteration. And so under fold here, we're going to pass in convert bytes to string, and that should allow us to perform the conversion. Now, ultimately, we want to make sure that we are getting our string back from here. So it looks like right now we are getting a little issue here. Let's see what's going on. Now, if we hover over this, you're going to see this error right here that says expected 2 arguments found 1. And that's because the fold function right here actually needs a value to start with as the accumulator. So that's the very first argument. So we'll say string from an empty string value, and that will serve as the initial accumulator value. And then we are getting another error here, and this is the one I was kind of expecting to get, where we have to declare our second input as a borrow of the unsigned 8-bit integer. So we'll do an ampersand right here for the data type. And then we can use a deref operator here to grab the underlying value of that pointer. All right, so now that satisfies the compiler, and we can go ahead and run our code and see what we get back. So now you can see it says data found is Trevor Sullivan. If we change this file to file03 and run it again, you can see we get Shannon Jones, because once again, each of these files has a different name inside of it, and we're just dynamically reading the contents of these files. So anyways, that's just kind of some of the basics of reading and writing data, dealing with directories, like creating directories, deleting directories, and things of that nature, deleting files as well off the file system. Since this video is getting kind of long, I'm probably not going to go into detail on the other types here, or other methods, I should say, that allow you to go into a file and kind of do micromanagement of the contents of that file. But that's probably a good topic to do in another video as part of this series. So if that's something that you want to see, make sure that you leave a comment down below and just say, yes, I would like to see that particular topic. Thanks for watching, and I hope you learned at least one thing new. Again, please leave a like, please leave a comment down below, subscribe to the channel, and hit that notification bell, because that helps you to get notifications about all the new videos that I publish, so you can get first access to them, and we'll see you in the next video. Thank you, take care.